Okay, Mr. Imran Mustaq. Um, do not mind the bad background and the very terrible setup that I have. Also, if you get to hear any kind of background noise, I'm just in my home. And secondly, I'm not that much of an expert in physics, but I will just tell you how much I know according to the question that you asked. So what you said was that, but as I followed from AI using Dirac's theory, psychat is a linear combination of orthonormal bases with complex numbers as coefficients. So what is psi? Let us understand. Let us consider that this is a box. Okay, this is a box, and the box has a quantum particle. The wave of the quantum particle can be represented like this. Now to mind that this is a probability wave. Quantum waves, or like the wave nature of a quantum particle is not a real wave. First of all, it's a probability wave. What probability wave means is that, let us suppose that this is an axis, this is an x-axis, this represents a real distance in meter. Let's suppose like this can be a line along the floor of your house. Now, if a particle exists somewhere, we are considering this strictly one dimension because two dimension is difficult to explain in a copy. But let us consider like one dimensional case. In one dimensional case, if a particle is here, then this probability wave that you are seeing, the amplitude has to be the highest in this position. But the thing is, a particle cannot exist only at one position in quantum mechanics. That's the issue. That's why we have a probabilistic interpretation of it. So we just assume that the highest probability of the particle being in this line is along this position. That's why we say that the amplitude is the highest here, and that's why also we take like the square of the amplitude. If psi is complex, psi be some kind of wave, then we take mod of psi square, because mod of psi square eliminates the imaginary part. Like the imaginary part that we have, we get eliminated. Then we get a real amplitude that tells us where the particle is most probably like to be. Now this psi wave can be, now this psi wave represents a physical particle obviously, but when we are performing calculations, psi is basically treated as kind of a vector. Now what are vectors? Let us say that this is a person, and that person moves along x-axis by 2 units and y-axis by 3 units. Then we say that the vector of the person will be 2i cap plus 3j cap. Now, vectors do not necessarily have to be always physical in nature. Vector can also be mathematical. This 2 or 3 can also be represented like this. This is used in mathematics and this is used in physics. Similar way, because quantum mechanics lies at a distinction between physics and mathematics, that's why we kind of keep jumping between these two. That's why we are using the what can we say, this mathematics system of matrices here. So psychat is a linear combination of orthonormal bases with complex numbers as coefficients. If this is a system and this is a particle, the particle can have, because the particle can be here, the particle can be here, the particle can be here. Or even if this is a system that has a lot of particles, basically the if the wave, like the quantum waves inside that box are going to be psi 1, psi 2, psi 3, etc., then the overall the wave nature of the box can be represented by this total wave function psi. So this total wave function psi is a superimposition of all the wave functions, individual wave functions that are present in the box. Now this is physics. To represent it in mathematics, we can also represent psi in a vector form. This is the vector form that I am talking about. Now psi, if we have to represent in a vector form, we will have to put in some kind of notation. That notation is called a bracket notation. But here the C is missing actually. It's a bracket notation. In the bracket notation, we have like two arrows here. If we have two arrows here, this is A and this is B. This represents the the bracket notation. Now if psi is represented in the bracket notation, it will be a superimposition of psi 1 plus psi 2 plus psi 3 plus dot 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 dot. Here psi 1 can be represented as by some amplitude. This is the amplitude that I'm talking about, okay? But here we are seeing as amplitude squared, because by default this amplitude is not physical in nature, and this axis that I'm representing is physical in nature. So this amplitude is complex. So here the amplitude that you're seeing, this is a complex amplitude, by the way. This cannot be represented here. To find the amplitude to be represented here, we will have to take the mod square of it. Now psi 1 is equals to be a e to the power I kx minus omega t. Let us put a minus sign here, or else when x tends to infinity, this wave function is not going to terminate. So if e to the power I x is going to be there, x tends to infinity, e to the power infinity it becomes. That means that this is probably not solvable. That's why we put a minus here, because if e to the power minus x is written and x tends to infinity, then we get e to the power minus I infinity, which is tends to 0. But t tends to infinity we do not write, because obviously we are not conducting an experiment for infinite amounts of time, but we can have like infinite amount of space in this universe. So this is more feasible to write. Now when psi is represented like this, this is a1 e to the power I kx1 minus omega t. Let's say time is constant, k1 into x1. This is a vector. If I represent psi 1 like this, then this psi 1 can be represented as let us say that this represents some kind of vector. Let us say that this is an e vector here, and then we are having a complex amplitude a1. In a similar way, psi 2 can be like a2. This is e1 vector. Let's say this can be e2 vector dot dot dot. So this psi can be represented as a summation of all these like complex amplitudes that we have here. Let us say that this a1 a2 I'm representing by c1 ci. I goes from 1 to n, because this will keep on going from a1 to an, multiplied by some kind of vector. Let us represent that the vector be I. This can be and also represented as an I vector. Does not matter. It's mathematics. That's the thing that's the thing that I'm trying to say. That this is mathematics. This is not physics. Physics is when we are going to like apply in some kind of systems. But this one is mathematics. So we can like use random terms. It does not matter. Now, if this is I cap, this can also be represented as j cap. Now, why are we doing this orthonormality? First of all, like what is the concept of orthonormality and why do we use it? Let us consider that there is one term A, there is another term B. When we multiply with each other, with A being some kind of vector and B being some kind of vector, then the product, if both of them is 0, then we call these two terms to be orthonormal with respect to each other. But why do we need like this orthonormality situation? So let us consider that there is a system and there is a lot of wave functions here, psi 1, psi 1, psi 2, psi 3, dot 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 something. And from here, let us this be one set plus psi 5, psi 6, psi 7, this be another set. So there is a lot of wave functions. So to make calculations simpler, if we consider the psi 1 and psi 5, the product of them is 0. And by product I mean the vector product, like the bracket notation. According to that, if that is equals to be 0, so what happens is that let us consider a simple linear algebraic equation, that x1 plus y1 plus z1 equals to be 0, x2 plus y2 plus z2 equals to be 0, or something like 36 or 42. These are just random equations that I'm writing. If we know that x1 multiplied by y2 is equals to be 0, y1 multiplied by x2 equals to be 0, if we multiply these two, because we need multiplication, as I said here, we can only treat square terms as like real entities. So it has to be either multiplied with each other and multiplied with itself. Why multiplied with itself? Because when you are multiplying two psi, basically this psi is a combination of psi 1 plus psi 2 plus psi 3. This psi is also a multiplication of psi 1, combination of psi 1 plus psi 2 plus psi 3. Let us put a dash here. Now psi 1 multiplied by psi 1 dash plus psi 1 multiplied by psi 2 dash. So they are like inner products are being coming out along with the self products. That means the products with itself, just in another form. Now here when we multiply these two algebraic equations, we will get like x1 dot x2 plus x1 dot y2 plus dot 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 plus x1 dot z2 plus y1 dot x2 plus something. So there are like self terms basically, because y1 dot y2 will also come, z1 dot z2 will also come. Those things are different. But if we know that x1 multiplied by y2 is 0, this term becomes equals to be 0. y1 multiplied by x2 is equals to be 0. This term is also equal to be 0. So a lot of terms get cancelled out, which makes the equation simpler. So that's the reason why we use orthonormality in quantum mechanics. Now similarly, if psi 1 and psi 2 are represented like this, here I'm using I and I'm using I. Let us represent it in a different way. Let psi1 be represented as a linear combination of all the complex coefficients c1 multiplied by some vector I, and psi2 be represented as a summation of all the complex coefficients c2 multiplied by j. Now when psi1 multiplied by psi2 we do it, then it has to be 0 if we are wanting to apply the orthonormality condition here. But we cannot just multiply these two and get 0. So how do we make the situation such as multiplying these two gives us 0? This is possible when we use the bracket notation, because in bracket notation, if I is a vector and j is a vector, and we have to multiply I vector by j vector, we do not do like this. This is a wrong process. Rather, we take the vector product. In when writing the vector product, it's either going to be uh, I j or like ji or something like this. Basically, these are two like these arrow brackets closing these two terms. This is a notation of the the products in case of the bracket algebra or the Dirac notation that we have here. Now when we use this kind of notation, what do we have here? I. What do we have here? J. And according to notation, if you have to multiply these two, we cannot just multiply psi1 psi2 like this. We will have to write like this: psi1 multiplied by psi2. When we write like this, what do we get? That first of all we get a linear combination of c1 multiplied by a linear combination of c2 multiplied by I multiplied by j. Now according to can you see it? I hope you can see it. Okay. Now in this term, this becomes equal to 0. So psi1 dot psi2 is equals to be 0. Then we say that psi1 and psi2, oh, without the brackets, then we say that psi1 and psi2 are orthonormal to each other. Orthonormal. So this is the concept of orthonormality that you asked. Sorry to explain it in a bit long, but I don't want to give you a wrong idea. That's why I said. And orthonormal basis coefficients reside in various 2D planes with each planes at right angles to all others. Yeah, because this thing you see in a vector, when we write like this is a vector, okay, this is like I cap, and this is a vector, let's say j cap. Now if I cap and j cap are perpendicular to each other, then what do we write? I cap multiplied by j cap, and what is this equal to? This is equal to 0. This is the like standard formula. I cap dot I cap is equals to be 1, and I cap dot j cap or I cap dot k cap, everything else is equals to be 0. That's why we used like the bracket notation here to convert them into vectors, so that we can like follow the basic rules of vector, like vector multiplication. Now now as you can see that these also reside in various 2D planes. In a similar way, you can also represent this is I and this is j. Now these are two vectors, by the way, in the Dirac algebra. I mean these are two vectors in quantum mechanics. These are vectors in just mathematics like the Cartesian frames. These are vectors in quantum mechanics. But we are being able to represent it so freely because these are mathematics at the end. As I said, like quantum mechanics mostly is mathematics, so we are using mathematics here. But you cannot directly use this in some kind of physical system because it will be wrong. We will have to get some solution out of it. We will have to find something, some substance out of it, then we can like apply in some kind of physical system with each plane at right angles to each other. Yes, like this one. We are what was psi1? Psi1 was yeah, this one. Psi1 was this one and psi2 was this one. These are two vectors which their like the coefficient corresponding coefficients being complex coefficients being perpendicular to each other. Here I cap is basically because if c1 is a, then I cap will be basically e to the power minus I kx minus omega t. There I'm just writing this in some kind of short form here. Now the net psi cat is a vector psi of x of t. Yeah, because psi of x of t, because we have x and t here, so the dependence comes upon x and t. Each complex coefficient is like the mod of psi I e to the power I phi t. Each complex coefficient is like the mod of ci Yeah, because CI is complex, so maybe that's why you wrote it like this: e to the power I phi t. Okay, e to the power I phi t is like, this is a whole another concept, phi of t. This refers to the phase angle basically. So um, if I have some kind of like, if I have this is a wave here, this is another wave here, so there is a exists like this thing, that exists a phase difference. So if we write this in terms of angles, then we call it a phase angle. So here e to the power I phi t, what is being represented, it is basically referring to the propagation of the wave, because it's a function of t, right? So the wave has to go forward in time, or the wave basically has to progress. Now as we are seeing here that the question is that, is the time part integral to the phase angle phi? Yeah, because if you see, if the wave does not progress ahead in time, then there is no phase difference. Phase difference comes only if one wave goes forward, then the another wave travels a bit backward, only then a phase angle can come. So here the phase angle is like, time part is integral to the phase angle phi, because yeah, that's, it's more of an intuitive kind of thing. If you have to think it intuitively, then you will understand that without this time thing, then, well, you can also like write like phi of x also, then you mean like the separation is based on position. But here when we are writing t, this basically means like this wave was emitted at t1 time, and this wave was emitted at t2 time. So this difference is causing the phase difference. From here we have the phase angle. So we are writing like the wave equations with respect with taking into account the progression of the waves. Yeah, that's how much I think I have to say. Thank you.